Hi, my name is Jonas Wilén and I'm a lecturer at KTH. And today we will present how to build a software makerspace or on-premise cloud. And this will only be a short introduction, and I will not present anything more or less. I will just introduce why we do this. The one presenter is going to be Pierre and Emil, who are currently pursuing a master thesis or master in distributed systems. And for KTH, why we need this, I think is pretty clear, but we go through it anyway. So, short introduction to KTH. KTH is around 50,000 students. We're the largest technical university at Sweden. And of those 50,000 students, around 1,500 is PhD students. Can I change here? Yeah. So this is our vision, especially for our department. And the vision is more or less that go from any idea to any material, make anything. So of course we have our research spaces, we have our educational spaces, we have our Makerspace, where we have our 3D printer, we can make PCB boards, laser cutters and so on. And we want to make the same thing available in any field. We're more focused in our department on health, but it could be any field. So if you take the part that we want to do is to figure out how to do it in a cloud space, because we have approximately, just in our group, around 300 software engineer students. So how do we solve them for them? And one thing I've seen when I've played around with this is that for our students, if you want to build a Facebook Lite, you need some couple of containers or a virtual machine. We can do almost that on a commercial system. You can get some virtual machines or containers on Google or Amazon. However, if you want to do some load balancing, some more complex thing, it's probably going to cost you money. And another thing we also realize is that if you want to use GPUs, machine learning, a lot of the lectures has been about that today, or the presentations, it's always going to cost you money. So we want the students to have a playground that's free to do crazy stuff on. So Emil and Pierre will now present how we made that happen.
Yeah, all right. So yeah, as Jonas said, we want to build a makerspace to build stuff. And to build stuff, you need tools. So having access to the correct tools and the right tools is really the name of the game. In a traditional makerspace, those tools, as Jonas said, could be a PCB printer, a 3D printer, or just a soldering station. But it doesn't just apply for traditional makerspaces. We also need tools, the software engineers. And what would those tools be in a university environment where we can explore and learn from just doing things? So yeah, what about the software engineers? Well, it turns out that we really need tools as well. We need to have some playground, which essentially means we want a computer, but not our computer, somewhere else. We want virtual environments, we want GPUs, we want compute power, and so on. So we figure we need to deploy all this ourselves using on-premise solutions. So yeah, but let's take a quick step back and see how we sort of thought this through, because it's really important that this was sort of easy to maintain, because it's sort of built by students for students. So going through the process, we like the analogy of using Raspberry Pis, because as a J-Focus attendee, you probably have at least one Raspberry Pi at home, collecting dust somewhere, and you might be running one or more Docker containers on it. But what if you want to scale it up? You need more Raspberry Pis. But now it's getting kind of annoying to move all around, all the Docker containers around and so on. So we automate it. We install Kubernetes. But now you want virtual environments, maybe with GPUs and so on. So you automate this as well. You use CloudStack, OpenNebula, or some solution that allows you to create VMs on some host. But now storage is getting tight, and it's getting, where should you put all the files you have? So you buy a Raspberry Pi, maybe with more storage, or you play it cool and you install Ceph on all the Raspberry Pis. Right, but now you have so many Raspberry Pis that it's getting annoying to install all of them, so you need to automate it as well. So you can use a provisioning tool such as Canonical Mast to install all the new Raspberry Pis that you buy. But after you've done that, you realize, wait, now it's getting so annoying to update all of my apps. So you need GitHubs or some way to deploy all your changes whenever you push to GitHub, or some CI/CD pipeline. So yeah, in just a few steps, we managed to go from this little thing to, I wouldn't say a private cloud, but I say you have the backbones to have a laboratory version of a private cloud. Yeah, so what did we do? Well, we can start from the left, where we actually have canonical MOS to provision and install all of our servers with the right configuration. And below it, we have something we call sys API. It's just an API that exposes metrics and GPU info, and we'll come back to why that's important later. On the right there, the logo with the monkey is CloudStack. CloudStack is this tool that provisions VMs and manages all of our Kubernetes clusters. It's sort of the backbone of this entire cluster and makes everything work together. In fact, we have a lot of more services to make everything sort of tied together, which run on top of VMs or Kubernetes clusters in CloudStack. One of those, some of those are DNS, our Docker registry, our identity management platform, and Rancher to manage all of our Kubernetes clusters. But coming back to the GPU part, because CloudStack does not directly support GPUs, at least like in the usable way. So we opted in for an abstraction layer we call deploy. Deploy is just a fancy name we have for an API written in Go that interacts with at least 5-6 services around the system, facilitating VMs with GPUs, website deployments, auto restarts whenever you push to GitHub, all the nice things you would like to have as a student when you learn to deploy in a cloud. So together with the frontend, a React frontend, we create a single point of the single platform for all of our services. So, all the buzzwords we heard from the last slides is now in one single service, and the students can, access this pretty easily. Much like the Google Cloud console or the AWS management console. Yeah.
Right. So thank you, Emil. That's really cool. But what does it actually look like from a student perspective? So let's say you're the student over there to the left. And you're sitting on your laptop and you're coding some super banger Rust application. And then you show your friends and it's very cool and it's very fast, but you want to make it public. You want to share a link to some people, post it on Hacker News. So traditionally you have public cloud, which is it can be expensive if you click the wrong boxes. You can self-host, which is fun and you learn a lot, but it's also can be risky to port forward your home network. And so now you have cloud spaces where you can deploy everything very easily with support of teachers like Jonas and TAs and whoever is hanging out in the Makerspace. So yeah, just a quick screenshot, but I think we have time for a live demo. Who wants to see a live demo? Yeah. Hold my beer. I need my hands. Yeah, so we've prepared. Ooh, I should be doing mirroring. So here you can see the dashboard. And so, we have, obviously it's AI, so, I want to say hello to YFocus. Okay. It's supposed to recommend if you need the Kubernetes or virtual machine. So let's create this. And so we have already 2 campuses in KTH, and it's very expensive with square meters in campus, but maybe we're going to have a 3rd one very soon. And so we can just very easily fire this off. And just to simplify, we support all the stuff you would expect, logs and health check and everything, just kind of what you would set up in Kubernetes, but with an interface more suited for a student. Where's my mouse? Here. And so here I have a Docker image prepared. And of course, I decided to bring a M1 Mac, so we have to build with a different platform. Okay. So boom, in I think just a few minutes, we've gone from idea, I want to make this website, and now you have a public URL, HTTPS, everything, ready to go. You can share it to Hacker News and all your friends. So yeah, this also allows us to host a lot of cool services. Like we've been able to host Llama 2 instances with multiple load balance server. So we have actually some projects that have been using it as their large language model. And we also have Stable Diffusion if you want some image content. And yeah, so you can see it's actually being used, like a few hundred containers. We have hundreds of cores, multiple campuses, lots of old computers as well, which allows us to sort of save the environment a little bit and use computers past their 5-year planned lifespan. Yeah, so what about you guys listening here? We're all open source. Everything is free. You can steal it all, or you can join the community. And we're very eager to add more campuses, more organizations. Just reach out and we'll be super happy to discuss. And so yeah, rounding off, you can try our platform. There's a free account, so you can try and pen test our system. Thanks.
Yeah, Jonas.
What if you're gonna change something after what we learned now, because you have done this for almost 2.5 years? What lessons learned have you done?
So the question was, what lessons have we learned along the way, and what would we change if we would redo this? Well, we had some issues with CloudStack, the sort of like core component of this of the cloud that create virtual machines. And there are a lot of newer, cooler technologies we can use. Like KubeVirt just announced that we can run everything on Kubernetes, which is a cool thing if you like Kubernetes, I guess. So yeah, that's one part. Yeah, but in general, I guess research, see what the better alternatives are. Yeah. Yeah, in the back.
So what's been the biggest hurdle, the biggest challenge?
Yeah, so the question is, what's the biggest hurdle in this project? And so I'd say it's the most boring one. It's, communication, organization, budget, like getting stuff. But if you were asking about like technologically, I think, we've had our small problems, but ever since we started coding everything as one big system, it's gone a lot easier. GPUs perhaps are a little bit, it feels like they're not sort of natively supported by many platforms. So it's always a hassle when somebody wants a GPU here and you have to do all the steps to bring it through the virtualization layers all the way up.
I would add one thing, that talking with Koto's item integration, because we are doing this on-premise with Koto's iPad, how to make it secure, what are we supposed to do? We're playing in a field that's somewhat scary to them. That is a problem. But I think this is necessary, because now the students that are here now they can both make the same thing you do commercially. They are familiar with how to play, and then the second step is that some students, not all, but some students are actually getting familiar also how you build your own cloud. Also, someone needs to know that as well.
Yeah, I think the important point to make is that we don't intend to be and offer all the things that are offered in a cloud like Oracle Cloud or whatever. But we offer sort of like a stepping stone, like, easy barrier of entry to getting to know all the features that you can do and how you build a website that can scale, how, you manage your resources and so on. So it's like things you normally don't do on your laptop, you can now do an experiment with here. Completely for free, as long as you're in KDH, of course. Yeah, that's a good question. The question is, what is the purpose of the API, our own abstraction layer on top of CloudStack? Well, I think the main, the reason we built it was because of lack of GPU support in CloudStack. So would that not have been the case, we might not have opted for that feature, because there are other platform as a service solutions for free that we could have used instead. But so it would, yeah, I guess we built it because we wanted to add a layer where students can feel that they can also contribute. Because if we only install like pre-existing hardware as well, software, it sort of becomes, oh, you just install some scripts and you have this done. But now you can tweak everything and you can see more of the mechanics behind everything that makes it work. We just need to draw the line where it's suitable for students and not like, we don't want to build our own Docker registry. That's unreasonable. But we draw the line where, oh, you can interact with the system, you can interact with Kubernetes in this API as we do, and you can interact with a VM service like CloudStack as we do. So it was, apart from the GPU support, we also wanted our own thing that students can also learn from, I guess. Yeah.
We have one question more, last one.
Yeah, so the question is just if we delete resources after some timeout, so we don't end up with a bunch of dead VMs. And so it's actually been brought up recently. We don't right now. We have a few thousand containers, not tens of thousands of containers, but it's something to think about for sure. And KDH deletes all the like Microsoft accounts when a student ends their term or like their registration. So I think it would be pretty suitable to just, you're done here, go on to some real cloud. Yes.
Right, yeah. Thank you.